All right, now, since you guys are year 12 now, because I can't do this to year 9 students, I'm going to pose you a fun little question that, well, I won't tell you the whole secret to it, but let me see if you can try and work it out. Let's play a game. It's me versus all of you guys, okay? And it's a coin flipping game, okay? So suppose the game is whoever's the first to flip a tail, because you can see I'm clearly into tails, right? Whoever's the first to flip a tail wins the game, okay? I go first because I have the coin and I say so, right? I go first. If I don't, if I get a tail, I win. If I don't get a tail, like I didn't, right? That means you get to have a go and you get to flip. Wow, that was a terrible flip, but that's okay. What'd you get? Head. Okay, so you didn't get a tail, right? Bad luck. And now it's my go again, okay? And then we keep going, right? And here's my question for you. I started, right? So you'd probably assume that I'm more likely to win, right? The question is, how much more likely am I to win, number one? And number two, how can you prove it? Because actually working out how much more likely I am to win is actually quite easy, but showing it, a little trickier, okay? There's a real clue there. You have a go. If you think you have an answer, call me over and I'll have a look. No spoilers, okay? So I'm looking for two things. Assume it's actually a fair coin this time. Number one, how much more likely am I to win? Number two, why? Okay, I'll give you a little time to think about that. Okay, I'm gonna try and explain. I'll admit I sort of threw you in the deep end a little bit because it's kind of like you sort of know what the answer is. It's twice as likely, by the way. I'm twice as more likely to win because I'm twice as awesome. No, anyway, but how do you show it? That is the hard part. Okay, and especially because this is a probability tree that never ends because you don't know how many turns it's going to take for someone to win. Right? We could be playing this for ages if we get lots and lots of heads. Okay, so here's the way that I would draw the diagram and prove it. Okay. The first thing that occurs is that there's two outcomes, right? Namely a tail or a head, okay? But you also need to indicate somewhere on your diagram that this is me and not you, right? So I'm just going to put down the bottom here. This is my turn, okay? So I don't need to put any probabilities on these just yet because they're equal, but I'm going to do it anyway. You'll see why in a second. So this is a half, and this is a half, okay? Now what happens? If I get the tail first go, it's game over. I've already won, okay? So this doesn't go anywhere. It finishes. It ends. But if I get a head, it keeps going, so there are more branches. Now, just like me, you've got two possibilities. So here you are. You can get a head or a tail, right? Now, the probability is still the same. The reason why I'm writing on there is so that the product rule is a little more obvious, right? Because what's your chance of winning? It's not the same as mine, right? Your chance of winning is not a half, it's a half times a half, because these events must happen together, simultaneously, right? So my first chance of winning at that point is a half, right? But then yours is a quarter on the second go. Now, you need to keep on going because you can see I haven't got all of the events yet, right? I'll know I have the entire sample space when all my possible events add up to 1, because that's the sum of everything, right? So I've only got 3/4. So there's a 25% chance that no one's won at this stage, right? So it continues. Now, if I'll do 2 more, and then I think it'll be obvious. This next time, I have a probability of an 1/8, right? It's a half again. And then the next time, you guys will have a probability of a 16, right? Okay, now, intuition tells you every time, right, we have our respective turns, mine is twice as likely as yours, and you can keep the pattern going. But how do you show it? Well, the probability of me winning, right, okay, is all of those together, right? You have to get all of them because that's why I have to keep going forever in order to get my sample space adding up to 1, right? So therefore, it's a half plus an 1/8 plus 32nd plus, and so on, forever. It's really important, okay? Now that's something you know, right? This is a series, okay? This is a series where that's equal to S of n, where, I should actually write where instead. What kind of series is it, by the way? It's geometric, right? Where my first term is a half. And my ratio is, what is my ratio? It's a quarter, right? So therefore, this is equal to, because that ratio is less than 1, it's got a limiting sum, so it's a on 1 minus r, right? So a half, there's a on 1 minus a quarter. Okay. So I've got a half divided by 3/4. So when you flip everything upside down, you're going to get 2 over 3. Okay. And naturally, the probability of you winning is the complement of that, right? So it's 1 minus me, so that's why it's a third, hence I'm twice as likely. Okay? So it's kind of neat because it's simple stuff, but it's an application of something which you don't usually connect to probability. Okay?